Okay, so to find the area of a triangle is just half of a rectangle. So that's why we do 1/2 of the base times the height. And so remember, the height has to form a right angle with the base. So that's an important thing. So we just plug into the formula. So the area equals the 1/2. This is our base, and this is our height. So the base is 10, and the height is 6.1, and you would just use a calculator. So we have 1/2 of 10 is 5, and then 5 times 6.1 is 30.5. The same thing on number 2, area equals 1/2 base times height. Our base is 9, our height is 6.4. So we have 1/2 of 9, which is 4.5, times 6.4, which is 28.8. And it would be inches squared. This would be miles squared.
I think I kind of get it.
You get it?
Yeah.
Okay, so you want to finish the rest on your own, or do you want me to go through them with you?
Can you go through them with me?
Sure. Yep. So number 3, the triangle's turn, but you can just turn your page and see that here's the base and here's the height. So again, we have 1/2 of base, which is 7, times height, which is 3.1. And we just simplify that on our calculator. 1/2 of 7 is 3.5 times our height, which is 3.1, 10.85. And it's kilometers, so kilometers squared. Area equals 1/2. What's my base?
5.
Very good. And what's the height?
5.7.
Perfect. And we just plug that into our calculator. 1/2 of 5, 2.5 times 5.7. That is 14.25. And since it's centimeters, centimeters times centimeters is centimeters squared. Number 5, 1/2 our base. What's the base, Jade?
5.
Good. And what's the height?
3.3.
Perfect. 1/2 of 5 again is 2.5 times 3.3. So the area is 8.25 square inches. Number 6, we have 1/2. What's the base?
6.9.
Okay. Times the height.
4.9.
Okay. Perfect. That's the hardest part. So 1/2 of 6.9 is 3.45, and then multiply that by 4.9. 16.905. Okay, then our area for number 7 is 1/2. Our base is 6.4. Our height is 6. So 1/2 of 6.4, that's 3.2 times 6. It's 19.2 centimeters squared. Number 8, we have 1/2 times, what's our base, Jade?
2.
Good. And what's the height?
1.7.
Good. Half of 2 is 1, and 1 times 1.7 is just 1.7. Number 9, the area is 1/2 of our base, which is 7, times our height, which is 6.6. So that's 3.5 times 6.6, which is 23.1 centimeters squared. And number 10, we have 1/2. What's the base?
8.7.
Very good. Times our height, which is
4.
good. And so 1/2 of 8.7 is 4.35 times 4, which is 17.4. Any questions on calculating the area of a triangle?
No. It's kind of confusing, the 8.7, but I know you have to just make a half of it, right?
Yeah. So, and you can use your calculator.
Mm-hmm.
So the easiest thing is, rather than doing 1/2, I just do 0.5. So I probably should have gone over this with you at the beginning. But you can just start by doing 0.5. You can just multiply straight across in order. So I do 0.5 times 8.7. Times 8.7, which is 4.35. And then multiply that by 4. And then that's how you get the 17.4.
All right.
Okay, so we're gonna move on to area of a parallelogram then, if you don't have any questions. Oops. Okay, so let's go ahead and take the notes for area of a parallelogram. So first, the definition of a parallelogram. It is a quadrilateral with 2 pairs of parallel sides.
The entertainer. That's what it was. It's a song.
So if you rearrange the parallelogram, it's actually just a rectangle. And so that's why we use the same formula as the rectangle, the base times the height, or the length times the width. If you cut off just this little end and stick it right here, it's just a rectangle. And so we calculate the area of a parallelogram by just multiplying base times height. So here our base is 5 and our height is 4. So the area equals base times height, which in this case, our base is 5, our height is 4. So the area equals 5 times 4, which is 20.
So this one you don't have to split or anything, you just multiply it.
That's right. There's just multiplying.
I still need 8.
So let's go ahead and look at your area of a parallelogram assignment in your workbook. So it's always helpful to just write the formula at the top. We said the area just equals the base times the height. So the area here, our base is 9, our height is 7. So we multiply 9 times 7, which is 63. And since we're doing area, we're multiplying centimeters times centimeters, which is centimeters squared. Same thing for number 2. Our base and our height. We multiply 4 times 1, which is just 4. So that's 4 square kilometers. Number 3, our base is 2 and our height is 2. So we multiply 2 times 2, which is 4 inches squared.
This one is way easier.
It is. Our base is 5.3, our height is 5. So multiply 5 times 5.3. Use your calculator since there's decimals. It's 26.5. So what would number 5 be?
5 times 2.5.
Mm-hmm.
Want me to see the answer too?
Sure.
Okay, give me a second. I'm trying to solve it. It's either 12.5.
Yep, that's right. 12.5. Do you have a calculator, Jade?
Not with me. It's somewhere in my room.
Oh, okay. Okay. What about on your Chromebook? I bet there's a calculator on there.
I think so. Let me see.
Because we're going to get into the trapezoids and you're probably really going to want a calculator for that one.
Okay.
And Ethan, we were playing a game on the Switch, and Ethan was beating me, and then I got up and he made the shot and he lost. Like a dump.
Hey, I'm in a meeting.
Are you in a meeting?
She's in class.
I want to take one.
Okay, I got it.
You got it? Oh, perfect. Okay. That makes it a lot easier. So the base for number 6 is 7. And then the height is 5. 7 times 5 is 35.
The potatoes are so good.
Katie, what would 7 be?
3.3 times 2.
You good?
Oh, you want to solve it too?
Sure.
Okay. 6.6.
Okay. So number 8, we have 6.5 and then 3.7. which gives us 24.05. And then what would 9 be?
8 times 7.
Very good.
Is 47.
Try that again.
Wait, oh my gosh, sorry. Oh my gosh.
I think it's 56, right?
Yeah.
Okay, and then number 10, we have our base, which is 9, and our height, which is 6.6.
Oh, 59.4.
Very good. Awesome. You've got it. Ready to keep moving along?
Yes.
All right. Let's switch back to our notes. Okay.
Okay. Tomorrow morning.
Where are you leaving today?
Okay, next we're going to do the area of a trapezoid, which is a quadrilateral with, this time it only has one pair of parallel sides. You sounds like you have a fun house over there, Jade.
Yeah. My mom's not here today, so my older cousin is taking care of us, and her daughter's here too, so there's a lot of kids as well.
Okay, so this one's a little bit more involved. And so it's just knowing how to use the formula. So the formula is 1/2 of B1 plus B2. So you add the two bases, take half of that, and then multiply that by your height.
This is kind of confusing.
It's not that bad. It looks intimidating, but once we do it, I think you'll see, oh, that's not so bad. And as long as you have a calculator, it's really not that bad. So you're just going to plug in everything you know. So we can just label. So this is B1, that's base 1. The top is base 2, and then 4 is our height, is our H. So we just substitute all those things that we know into our formula. So we have 1/2 times B1, which is 8. Oops, I didn't mean to do that. Plus B2, which is 6. And then multiply that times our height, which is 4.
Would you distribute?
You can. I think it's easier to just simplify the parentheses first.
Oh,
So I would do 1/2 of 8 plus 6. So 6 plus 6 is 12 plus 2, that's 14 times 4. And then it's easier math. So half of 14 is 7. And so 7 times 4 is 28.
all right.
Let's do another one. So let's go look at your assignment. Give it a minute to soak in. Area equals 1/2 of B1 plus B2 times the height. And let me know if I'm going too fast.
Okay.
Okay, so we can go through and label first. So we could say B1, B2, and our height. And it doesn't really matter the order of B1 or B2. If you label this one B1 and this one B2, you'd still get the same answer. And then we just plug into our formula. So area equals 1/2. B1 is 3.2 plus B2, which is 9, and times our height, which is 8.1. So any questions how I got that first step?
No, I got that.
Okay, perfect. Now it's just simplifying. So we follow PEMDAS. So you always do your parentheses first. So 3.2 plus 9 is 12.2. And then we have to still multiply that by 8.1. And then I would just use a calculator at this point. And so just go in order. So we have 0.5 because 1/2 is just 0.5. And you could do 1/2 and it'll give you 0.5. And then multiply that by 12.2, which gives us 6.1. And then we have to now multiply that by 8.1. Oops.
Or did everyone?
We were at 6.1 and 8.1. Which is 49.41 kilometers squared.
Yeah, she needs a person. And yeah.
Any questions on number 1?
No.
Okay. Number 2, we have B1, B2, and our height. So we have 1/2 of 7.6 plus 3.8 times our height, which is 5. And we'll do our parentheses first. So 7.6 plus 3.8, which is 11.4 times 5. And then we'll use a calculator. 0.5 times 11.4 is 5.7 times 5, which is 28.5. You want to try number 3?
Sure.
Okay.
2.3
Good.
plus 1.1
Very good.
the outside times 2.
Perfect. And then what are you going to write on the next step?
2.3 plus 1.1, so 3.4.
Very good.
Times 2.
Good. And then go ahead and do it on your calculator and tell me what you get.
I got 1.7, but then times 2
Mhm.
be 2.
Try 1.7 times 2 again. Should give you something else.
Oh, 3.4.
Good job. That's exactly right. Very good. Oops. So number 4, we have 1/2 of our base, which is 9. Base 1 plus base 2, which is 3.6. That's our height, which is 8. We'll simplify our parentheses. 9 plus 3.6, 12.6. Times our height, which is 8. And then we have 1/2 of 12.6, which is 6.3, times 8, which is 50.4. All right, you want to do 5 and 6?
I could try.
Okay.
So 1/2, 7.9 plus 2.9 times 4.5,
Good.
and then let's see. Um, 10.8, and then 10.8 times 4.5.
Very good.
And then 10.8 would turn into 5.4 times 4.5 would be 24.3.
Yep. Very good. You've got it.
The next one too?
Yeah.
Okay. 1/2, 2.6 plus 7 times 3.
Very good.
Um, 9.6 times 3,
Good.
and then 9.6 would turn into 4.8,
Mhm.
and then 4.8 times 3, 14.4.
Excellent. You've got it. Was it as bad as it looked?
No, it was,
I know it looks scary, but it's really not that bad.
yeah.
Okay. Now we are going to do areas in a coordinate plane, which there's no notes for because we're going to use those same formulas that we just went over. It's just on a graph. So you're gonna graph these points and then figure out the shape, the formula, and then calculate the area. So remember when we graph X and then Y. So our first point A is X is 3 and Y is 2. So we go over 1, 2, 3 and go up 1, 2, and that's A. If you want to, you can label. Any questions how I graphed A?
No. I got
Okay. Then B is 3, negative 2. Go to 1, 2, 3. X is 3, Y is negative 2. That's point B. C is negative 1, negative 2. Swap that point and label it C. And D is negative 1, positive 2. And that's our D. And so what shape is this? Let's see, we have 1, 2, 3, 4. Our length is 4 and our width is 4. So what shape is this?
square.
Yep. And how do we calculate the area of a square?
I forgot.
We didn't cover it. It's the same as a rectangle.
By area and perimeter.
Yeah, so a square is just a rectangle where all the sides are equal. So it would just be the length times the width, which our length times width is just 4 times 4, which would be 16.
Okay.
Any questions on number 1?
No, I got that one.
Okay, perfect. Okay, let's graph number 2. So we have 4, negative 3. Do you need me to label the grid or are you good just counting the boxes?
I'm good.
Okay, so 4, negative 3, 1, 2, 3, 4, negative 3. That's point E. F is 0, negative 3. So X is 0 right here. Y is negative 3. There's F. G is 0, negative 2. 0, negative 2. And H is 4. 1, 2, 3, 4, negative 2.
Is it supposed to be spicy? Oh, I thought it was. Never mind, I confused myself. I thought it was a banana.
So what shape is that?
A rectangle.
Good. And what's the formula for a rectangle?
Length and width.
Good. And so what's the area calculation?
4 and 1.
Good. Which is
4.
perfect. Okay, let's do number 3. We have negative 2 is 0. That's point I. Negative 2, 4. 1, 2, 3, 4 is J. And K is 1, 0. So what shape is that?
A triangle.
Good. And what's the formula to calculate the area of a triangle?
The base and height.
You're missing one part.
Area.
No, it's not just base times height, right? Because that's the same, that would be a rectangle, right? So a triangle is how much of a rectangle?
I'm confused with this one.
Do you have your notes for the area of a triangle?
Yeah, it says base and height. I wrote base and height, that's it.
Uh-oh. What about on the area of a triangle assignment that we just did?
One half of equal base.
Right. Yeah, a triangle is half a rectangle. And so that's why you have to cut it in half, the base times the height, because a triangle is only half of that. And so let's see, our base is 1, 2, 3, and our height is 1, 2, 3, 4. So we do 1/2, our base is 3, and our height is 4. And so I would do 3 times 4 first, which is 12, and then cut that in half, which is 6. Okay, number 4, we have -4, -3, 1, 2, 3, 4, and -3. That's L. M is -1, -3. That's M, and N is -2 and +4. So clearly that's a triangle. And so we'll use the same formula used on number 3, which was also a triangle. So you do half of the base times the height. So what's our base?
3.
Good. Okay, and then our height, remember it has to form a right angle. So this right here is going to be our height because that forms a right angle with the base. So that is 1, 2, 3, 4, 5, 6, 7. So we do half of 3 times 7, which 7 times 3 is 21. And then if we cut 21 in half, that would be 10.5. Any questions, Jade?
No, I got that one too. That one was pretty easy.
Okay, awesome. Okay. So that was all the notes and assignments for Unit 2. So let's go ahead and move on to Unit 3. So let's do the little, actually, before we do that, there's a little intro. The first assignment. So it's the second page up. the first page, the back of the first page after the Unit 3 tab. Okay, so Unit 3, you'll be learning about 3 different transformations. So transformations only change the positions of the figure. They do not change the shape or size. So we're going to be doing rotations. So rotation means that you just turn the figure. So see how the R was just turned?
Yeah.
A reflection, so if you look at the letter R, it was just flipped. It just flipped to be the mirror image. So reflections is where we're going to be flipping. And then the translation, you'll see it didn't change its orientation. It just slid. So this is a slide. It just slid to the right. Okay, so now you go ahead and try it. So rotate, reflect, and translate the letter E. So for the rotation, you're going to just turn the letter E. So maybe so it could be something like this. I just turned it. The reflection, you're going to flip it. So you're going to draw its mirror image. And then the translation is a slide. So you could slide it, you could just slide it to the right, you could slide it to the right and down, to the right and up, to the left and up, to the left and down, wherever you want. So this would still be a translation. I slid it down and to the left. Can move it anywhere.
Miss Moore, my internet's not working. You keep on going out.
Oh, bummer. Is it still doing it?
Yeah, it keeps like I can hear like pieces of what you're saying.
Bummer. I'm not sure what to do. Do you want to try to leave and come back in? I don't know if that would help or so the first translation or transformation we're going to talk about are reflections. A reflection is a transformation that flips a figure across a line.
You want to go around
Sorry.
nearby where the just do this. You're gonna find a lot of fish. And again, that shelter.
And that line that we flip it across is called the line of reflection.
Hopefully nobody is sleeping on the sidewalk. It's nice to have a shelter, right? You can lock the door at night. You're safe in there. For the shelter idea, place the lid of shelter is really an important idea. And there's a lot of competition for it. All right, Dan, thank you, man. Getting us started. I like that. Okay.
So they're going to give you a figure like this triangle
Let's go to Charlie Rose.
and tell you where to reflect it. So we have A, B, C. And I want you to reflect across the y-axis.
And again, if something technical comes up, you can always hit me with the chat. Okay? Let's try Anaya Smith. Anaya Smith.
So here's the steps. First, you're going to highlight.
Okay, your voice is soft, but I can hear you. I'll turn up my hearing aid. Okay.
the line of reflection, which we won't write it every time. We'll use the abbreviation LOR. So it's telling us to reflect across the y-axis. So the y-axis
All plants do. It's really
is this one right here. And so we highlight that.
there we go. Now don't say it like it's a question. Say, oh, they
Once you
do
do that, step 2 is to count the distance from each point.
So, go to sentences. We can never, ever, ever stop talking about
To the line of reflection and count the same on the other side and
It's
stop.
like, I would hope you do too. And again, that's putting out.
Okay, so point A, from the distance from the line of reflection is 2 units.
Get up very early in the morning.
So if it's 2 units to the left to plot the reflected one, we're going to count 2 units to the right. And that is our reflected point. And so we call that A prime. You put a little apostrophe, and that means that's the reflected point.
Kind of made me think about
And then we count B. The distance from B to the line of reflection is 1. So we start the line of reflection and we count 1 the other way.
Can you give me another thought?
And that's B prime.
Why is the calculus so important?
And then C is 1, 2 from the line of reflection. So we count 2 on the other side, 1, 2, and there's C prime.
I like the way she
And there is our reflected triangle. So if you fold your paper on the line of reflection, the images would be right on top of each other. They're exactly the same.
And Luna, while I got you, one more slide.
Right.
Because I know you'll nail this. What's the term?
How do you feel about that, Jade? Any questions so far?
Ransom?
Nope.
URA?
Okay, so we'll do one more example. We're going to reflect across x equals 1. Okay, and the image that they're giving us is A is at 5, 1. Point A. B is at 4, 2.
How about my friend Daisy Carpenter? Daisy Carpenter?
I can't see it.
How you doing today?
3, 0. Oh, sorry about that. There you go. I'll give you a second to get caught up.
Your voice is a little soft, but I can hear you. So why does a horn shark need a lot less than a sea otter? Good. They use less energy. What was the main thing? I mentioned something about the blood. There you go. Now put that together. There. Put
Let
all
me
that-
know, Jade, when you're ready for me to keep going.
I'm ready.
Okay.
There you go. They're cold-blooded. They're
Okay, so you're going to be given that. And then now we need to reflect it across x equals 1. So x equals 1. If it's x equals, remember, that's going to be a vertical line. So we go where x equals 1. And all of these points are where x equals 1. So there's our line of reflection. And then we're just going to count. So I'll just start at the top. So B is 1, 2, 3 away from the line of reflection. So we'll go 1, 2, 3 on the other side, and that will be a reflected B. Then A is 1, 2, 3, 4 from our line of reflection. So we'll go 1, 2, 3, 4 on this side of our line of reflection, and that's A prime. C is 1, 2. So we'll go 1, 2 on the other side, and that's C prime. And I forgot to label D. D is 1, 2, 3. So we'll go 1, 2, 3. And there's D prime. So if we flip this figure across x equals 1, we'll get this figure. Any questions? Nope. Okay, let's look at your assignment. Okay, so the first one is a reflection across the y-axis. So step 1 in our notes is to highlight the line of reflection. So the y-axis, that's this one, that's labeled y. Then we're just going to count our points. So I go 1, 2, 3 to T. So I'll go 1, 2, 3, other side of our line, and that's T prime. S is 1, 2. So I'll go 1, 2 to the left. And that's S prime. U is 1, 2, 3, 4, 5. So I'll go 1, 2, 3, 4, 5. And that's U prime. So there's our reflected triangle. Okay, number 2, a reflection across the y-axis. There's our y-axis. And T is 1, 2, 3, 4. So we're going to go 1, 2, 3, 4 on this side, the left side. S is 1 to the right, so we'll go 1 to the left. That's S prime. U is 1 to the right, so we'll go 1 to the left, and that's U prime.
I already completed it and she's just saying what it is.
Any questions on 1 and 2?
Nope.
Okay. Number 3, we have to reflect across y equals 1. So y equals 1. Right here, that's where y equals 1. It looks like our first point is actually on our line of reflection, so it's going to stay there. W is 1, 2, 3, 4. So we'll go 1, 2, 3, 4. And there's W prime. And then V is 1, 2, 3, 4 from here. So we'll go 1, 2, 3, 4. There. Connect our point. Okay, why don't you try number 4 on your own, and then let me know if you have any questions.
Okay.
So Ashley, give me the 2 names of the graziers I mentioned. Absolutely. Thank you, Ashley. So, first off, what are graziers? That's your. As Ashley said, snails. A lot of different snails in the ocean. And then the guy we're going to put kind of a special focus on today. Are you on mute? Purple sea urchin.
No.
Okay. about this for a second. When I say what is their niche, if you look at these equals,
Okay, finished.
what's the grades first?
Any questions?
Nope, I got it.
Okay, let's.
You give us all out last. Okay. So.
Okay, does it look like that?
Yes.
That's their
Awesome. Okay, go ahead and do number 5 and 6.
5 and 6.
Yeah.
All right.
and they're being fed by these. So now, guys, let's put those in the sentences. Is that
Let's see.
what their niche is?
Oh, no.
So first, this arrow pointing down says that they feed on shelf. Remember, grazers, herbivores. Like cattle graze in a field. Sheep graze in a pasture. Right? So these guys graze on the ocean floor, but they're going to eat kelp, the plant that's there. And by them feeding on the kelp, they kind of keep the kelp in balance. Now look at this arrow pointing down on the apex. So their second primary niche, they are a food source. Food source to who? Oh, the guys at the top. Apex consumers. See how that works? See how that works? All we're doing, guys, is we're putting words to the diagram. Okay. I've got that diagram right here in my notes. Same diagram you guys have. I hope. You should have. Okay. Without all the details. But that's what the diagram is telling you. Seems like if you see a graph of anything, graph is worthless if you can't read it. It makes sense of it, right? What does the graph tell you? That's what's important.
I finished both of them.
Translate.
Okay, perfect. You want to check them with mine, 5 and 6, and then see if you have any questions?
What I have a bad habit of doing is I talk too much. And then I think everybody got it. And
I
then
keep on doing it on the wrong
don't
side.
really get it. It's too deep at all the time. I just sat here and listened.
So is your y equals -3 going this way,
Anyway, notice,
Yeah.
like this?
we have blue thumbs up right
I
now.
keep on doing it. Okay, can I share?
If
Let
you
me see if I can share.
have the notes so far, and you're ready for a little break.
I did it side by side instead of.
Okay, yes. So you want to make sure you draw your line of reflection first, which is y equals -3. So y equals -3 right here. And so you just draw a line all the way across y equals -3. And then you have to reflect across that line. So you count the points from that line up to D, which is you go up to. So then if you're reflecting across that line, then you would go down to
Marquis,
Oh.
for your reflected image.
Terrence Joseph. What's that guy? Justin.
Yeah, so just make sure to draw your line of reflection first. And then the same thing for x equals 1 right here. This is where x equals 1. So you just draw a line all the way through x equals 1.
Oh, okay.
And then you'd count. So v is 2 to the right. So you go now 2 to the left of that line for your reflected point.
All right,
Okay, I get it now.
guys, we won't make an official 10-minute break, even though I can get a thumbs up.
All right.
It's about every one person still. I won't say it. The last 5 minutes.
Let me know when you're ready. And then let's just try one more. I just want to make sure you have it before we move on.
Yeah, I'm ready.
Okay, let's flip to the next page. Oh, we already know the y-axis though. Okay, what about for number 8? So draw your line of reflection. So where's y equal to -2? And then if you can show me again, and then we'll make sure.
Right here. Oh. Hold on. I drew another line. It's right there.
Okay, so that one would be x equals -2. So if it's y equals -2, you want to go on the y-axis. So this one's our y-axis. So where y equals -2 would be right there. And so that's where your line would be.
Okay. So then I would draw it on top.
Yep, exactly. Right, so if you folded it on this line, the images should be right on top of each other. That's right, so since that one's below the line, then you would count above the line. So if it's 2 below, then you'd go 2 above, and that's B prime. And then D is 1, 2, 3 below, so you go 3 above. And then C is 1 below, so you go 1 above, and there's C.
Okay, I got it.
Okay, and just, we might as well do these ones because it's the rule, so it's different. So to figure out the rule, you need to identify the line of reflection. So it looks like right here, if we folded this graph on this line, they would be right on top of each other. And so this is a reflection across the y-axis. So there's the y-axis. What do you think number 10 is?
I think that one's also across the y-axis.
So you're close. So, but which axis is that?
Oh, the x-axis.
The x-axis, right? Yep. So that one would be a reflection across the x-axis. Good. And then number 11, we want to find the line where it's the equal distance to both. So that looks like that would be here, right? Because then n is 1 and n prime is also 1 away. And so this line is going through the y-axis at 1. So this is a reflection across y equals 1. And so we know number 12 is also a reflection. What's the line of reflection? So since it's going through the x-axis, it's x equals 1, 2, 3. So that one's a reflection across x equals 3. Any questions on reflections?
Nope.
Okay, let's move on to translations then. Okay, so like we said in our little intro, a translation is a transformation that slides every point in a figure the same distance.
Are we skipping transformations?
Which one?
Transformations. It's right after. Oh wait, we're skipping reflections too.
Yeah,
Oh, okay.
those are just extra practice problems, which I'll tell you which ones to do when we're done.
Okay.
Okay, so a translation is a transformation that slides every point in a figure the same distance. So we'll have to sketch it ourselves for our notes. So A is going to be at 2, 2. B, or sorry, negative 2, 2. B is at negative 2, negative 1. C is at negative 1, negative 1. And then they'll tell us how they want us to translate. So in this case, translate 3 units right. So all that means is we're going to pick up every point and move it 3 units to the right. So we're going to take point A, we're going to move it right 3. 1, 2, 3, and that's A prime. B, we're going to pick it up and move it 3 units to the right. So 1, 2, 3, and that's B prime. And C, we're going to pick it up and move it 3 to the right again. 1, 2, 3, and there's C prime. Okay, so this one we're going to translate 2 units right and 4 units down. Here's the graph. So A is at negative 2, 3. Negative 2, 1, 2, 3. B is at negative 1, 3. D is at negative 2, 1. And C is at 0, 1. Do you have the graph down or do you need a second? Okay, so if we're going to translate 2 units right and 4 units down, that means every point is going to go 2 units right and 4 units down. So we'll start with A, and we'll go 1, 2 units right, and 1, 2, 3, 4 units down. That's our translated A. Then B, we're going to go 1, 2 right, and 1, 2, 3, 4 down. There's B prime. C, we're going to go 2 units right, 1, 2, 3, 4 units down. And D, 2 units right, 1, 2, 3, 4 units down. And there's our translated trapezoid. Okay, let's go ahead and look at the translation assignment. So again, we're just going to move each point, however many it tells us. So 5 units down. So each point is going to get slid down 5 units. It's going to slide down 5 units. 1, 2, 3, 4, 5. That's R prime. S will move down 1, 2, 3, 4, 5. S prime. T 1, 2, 3, 4, 5. T prime and U 1, 2, 3, 4, 5. That's U prime. Number 2, you're going to move it 4 units left. So you're going to pick up each point, move it 4 units to the left. So U 1, 2, 3, 4 units to the left. There's U prime. B 1, 2, 3, 4 units left. That's B prime. And T 1, 2, 3, 4 units left. And that's T prime. Number 3, you're going to go 3 units right. 1, 2, 3 units right, and 5 units down. 1, 2, 3, 4, 5. That's B prime. A, we're going to go 1, 2, 3 to the right. 1, 2, 3, 4, 5 to the left. Sorry, 5 units down. And C, we're going to go 3 to the right. 1, 2, 3, and 5 down. 1, 2, 3, 4, 5. Number 4, 3 units left and 2 units down. 1, 2, 3 left, 1, 2 down. That's D prime. C, 1, 2, 3 to the left, and 1, 2 down is C prime. E is 1, 2, 3 to the left, and 2 units down. That's E prime. Number 5, we're going to move every point 4 units down. So J is just going to go down 1, 2, 3, 4 units down. K, 1, 2, 3, 4 units down. L, 1, 2, 3, 4 units down. And I, 1, 2, 3, 4 units down. That's I prime. We'll do one more, 5 units right and 5 units down. So we'll do S first, 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 down. So S prime, R, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So R prime, 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 down.